Nvidia's most valuable customers are building chips to replace it. That sentence needs to hold its weight because the scale of what is shifting beneath the AI hardware market is still poorly understood outside the semiconductor industry. A structural realignment is underway, not a disruption narrative, not a single competitor gaining share. But what happens when the 5 largest technology companies on Earth simultaneously decide the GPU supply chain they helped create is now a liability? And what happens to the one company at the center of all of it? For most of the last 3 years, the architecture of AI infrastructure was simple. Nvidia made the chips. Hyperscalers bought them. The loop ran in one direction, and the unit economics of AI deployment were largely determined by one company's production schedule and one company's pricing. The speed at which AI reached users, the cost of each inference request, and the competitive position of every cloud provider in the world were each downstream of what Nvidia decided to build next. That dependency, concentrated, expensive, and strategically uncomfortable for companies generating hundreds of billions in annual revenue, is exactly what the hyperscalers are now spending to dissolve. What is unfolding is not a clean break. Nvidia still generates more data center revenue in a single quarter than most semiconductor companies earn in a decade. Its Blackwell architecture is in volume production. What breaks a dependency like this? Not a better chip, a better supply chain. Its CUDA software ecosystem has created foundational friction for any competitor attempting to displace 20 years of accumulated developer tooling. Its Vera Rubin platform, which Bloomberg confirmed entered production in January 2026, is already positioned as the dominant AI compute layer for the second half of this decade, and its NVLink interconnect fabric, now open to third-party accelerators under the NVLink Fusion program, extends that ecosystem further, locking adjacent silicon into Nvidia's networking architecture even as hyperscalers build alternative compute. If a break from GPU dominance is coming, it will be slow, partial, and constrained by physics rather than competitive intent. So where is the money going? The capital allocation data makes the direction of travel legible. According to TrendForce's January 2026 market analysis, the top 5 North American cloud providers, Google, Amazon, Microsoft, Meta, and Oracle, are expected to increase combined capital expenditures by 40% year-over-year in 2026. A growing and measurable share of that capital is routing toward custom silicon designed, owned, and operated by the hyperscalers themselves. The embedded logic is direct. A company controlling its own chip architecture controls its own cost structure, its own performance roadmap, and its own leverage in any commercial negotiation with a concentrated single-source supplier. Custom silicon programs at Google, Amazon, Microsoft, Meta, and OpenAI are not strategic experiments. They are primary capital commitments responding to a specific and calculable dependency. The first tension in this market is the growth differential that has opened between custom chips and general-purpose GPUs. According to TrendForce's January 2026 press release, custom ASIC shipments from cloud service providers are forecast to grow 44.6% year-over-year in 2026, against a 16.1% growth rate for merchant GPU shipments. Nearly a 3-to-1 differential. ASIC-based AI server systems are projected to account for approximately 27% of total AI server shipments by end of 2026, compared to roughly 21% in 2025. Alchip Technologies. Chairman Johnny Shen, speaking in May 2026 comments reported by Digitimes, described the movement as hyperscale customers, pursuing performance, power efficiency, and system-level optimization required for next-generation AI workloads. Why is that ratio widening? The answer is specific. For predictable, high-volume inference workloads, a chip designed for a single purpose substantially outperforms one designed for general use. The economics from Google make the incentive concrete. Google's 7th-generation tensor processing unit, codenamed Ironwood and announced at Cloud Next in April 2025, delivers roughly 4,600 FP8 teraflops per chip with 192 gigabytes of HBM3E memory. Tom's Hardware's May 2026 analysis reported that Google's own procurement data places Ironwood's total cost of ownership approximately 44% lower than a comparable Nvidia GB200 server. That figure comes from the internal economics of the company running both hardware stacks at scale. Here is what the custom silicon narrative has not yet fully priced in, and it changes the timeline on everything that follows. The second tension is the competitive architecture assembling around Nvidia. Amazon's Trainium and Inferentia processors handle a significant share of AWS machine learning workloads. Microsoft's Maya 100, built on TSMC's 5-nanometer process, serves inference for OpenAI's models across Azure. Meta, despite its own MTIA accelerator program, committed to multi-billion-dollar TPU deployments with Google in early 2026, signaling how wide the maturity gap remains between Google's silicon and the alternatives. OpenAI is developing its first custom ASIC through a reported $10 billion Broadcom partnership targeting late 2026 deployment. Broadcom and Marvell together control an estimated 95% of the custom AI ASIC co-design market, functioning as the engineering translation layer between hyperscaler intent and manufacturable silicon. Broadcom reported $8.4 billion in AI semiconductor revenue in Q1 fiscal 2026, a 106% increase year-over-year per the company's earnings filing, with CEO Hock Tan projecting approximately $56 billion for full fiscal year 2026, roughly 180% growth over fiscal 2025, backed by a disclosed $73 billion AI backlog. In April 2026, Broadcom and Google formalized a supply agreement extending their custom chip partnership through 2031. Nvidia's own filings provide the essential counter-context. The company's Q1 fiscal 2027 SEC filing reported data center compute revenue of $60.4 billion, up 77% year-over-year, with total data center revenue reaching $75.2 billion. Semi-analysis, InferenceX benchmark data cited in Nvidia's Q4 fiscal 2026 earnings found that Blackwell Ultra delivers 50 times better performance for agentic AI versus the Hopper platform. Nvidia retains approximately 70 to 80% of the AI accelerator market by revenue. The company is not in retreat. What the Broadcom trajectory and the Nvidia filings together describe is a bifurcated market, one track running on general-purpose GPUs for training and research, where workload flexibility matters more than efficiency, one running on purpose-built ASICs for inference at hyperscaler scale, where predictable workloads and extreme volume make single-purpose silicon economically compelling. That split is not a transitional condition. It is the settled architecture of AI compute, the endpoint toward which the market has been moving since the largest cloud providers recognized that hardware concentration creates systemic vulnerability at sufficient scale. The third tension is the one most analysts ignore entirely, and it sits beneath every shipment figure in this story. Advanced packaging is the binding constraint on AI hardware production in 2026. TSMC's chip-on-wafer on substrate process, CoWoS, stacks high-bandwidth memory beside compute dies on a silicon interposer, enabling the memory bandwidth that high-performance AI accelerators require. Without this step, even a chip designed on TSMC's most advanced 3-nanometer node cannot function at AI accelerator performance levels. Per foundry tracking data through June 2026, total CoWoS wafer demand is estimated at approximately 1 million units for 2026, up from roughly 370,000 in 2024. Nvidia holds an estimated 60% of TSMC's total CoWoS output through 2027, secured through forward purchasing agreements finalized well before most competitors recognized packaging as the decisive variable. TSMC CEO C.C. Wei confirmed publicly that capacity remains very tight, characterizing AI demand as embedded rather than cyclical. TSMC reported a 58% profit increase in Q1 2026 and forecast full-year revenue growth exceeding 30% year-on-year. That concentration creates an asymmetry that quarterly earnings reports rarely surface. The 44.6% ASIC shipment growth TrendForce projects for 2026 is a packaging-constrained figure. What can actually ship given current foundry allocations, not an unconstrained demand estimate? The real demand for custom AI silicon is meaningfully higher than what the foundry can currently serve. And Nvidia's competitive position is not solely a function of Blackwell's performance benchmarks. A baseline component of that position is that Nvidia secured approximately 60% of the world's primary AI chip packaging capacity, years before competitors recognized that packaging, not wafer fabrication, not architecture, was the production bottleneck. Custom chip programs carry constraints that shipment growth projections do not communicate. A purpose-built ASIC requires substantial upfront engineering investment and typically takes years from architectural commitment to volume production. The economics justify that investment at hyperscaler scale, for companies deploying hundreds of thousands of accelerators on predictable workloads. They do not justify it for the majority of companies deploying AI infrastructure, which will continue purchasing general-purpose GPUs from Nvidia or AMD. The two-track market does not offer symmetrical access. It divides in favor of the largest spenders, and the gap between what a hyperscaler can build and what a mid-sized enterprise can procure will widen as custom programs mature. What have the hyperscalers actually done? They have built custom silicon and simultaneously expanded their Nvidia contracts. Google is simultaneously Broadcom's primary custom chip customer and one of Nvidia's largest revenue contributors. Meta signed a multi-year partnership with Nvidia in fiscal 2026, covering large-scale deployment of Blackwell and Rubin GPUs alongside its own MTIA program. Amazon operates both Trainium-based and high-end Nvidia GPU instances across AWS at significant scale. The competitive dynamic is not substitution. It is portfolio diversification, which means Nvidia's current revenue base is more durable than a simple share shift analysis would suggest, even as the custom silicon segment grows faster in shipment terms. TSMC is adding CoWoS capacity at roughly an 80% compound annual rate, but from a fully committed base, meaning each new increment is absorbed before it meaningfully expands market access for new entrants competing against Nvidia's existing allocation. Intel's EMIB and Foveros packaging technologies offer an alternative pathway at domestic U.S. facilities, though neither has yet demonstrated the throughput or yield rates required to serve as a primary AI accelerator packaging source at production volumes. Broadcom's disclosed roadmap includes a next-generation TPU training chip, codenamed Sunfish, targeting TSMC's 2nm node for late 2027. Procurement decisions finalized in mid-2026 produce deployed infrastructure in 2028 and 2029. Does the AI hardware market beyond the GPU era mean a market without Nvidia? Number. It means a divided one, where general-purpose GPUs retain dominance in training and research, and purpose-built ASICs claim the inference layer at hyperscaler scale. What neither track fully controls is the physical substrate enabling both. The packaging lines, the HBM allocations, the 2nm wafer commitments already spoken for through 2028. The company that reserved those resources first holds an embedded advantage that architectural innovation alone cannot replicate on any near-term timeline. If the packaging bottleneck just reframed how you think about this market, drop a comment below with one word: bottleneck. And if you want the next layer of this story, where AMD, Intel, and the next wave of challengers actually stand inside this same constraint, that video is queued up next. Facts over fear.